Hello everyone and welcome to this lecture. In this lecture, I'm going to walk you through how can we perform image cropping, how can we perform dilation and erosion. All right, so let's get started. First, we're going to load our image. If you guys wanted to download the image, you can download the image from here, or you can find it as well in the course package. It's simply the self-driving car.jpg, so shift enter. Here we simply have our self-driving car image. We visualized that before and we know exactly what that is and all the dimensions of the image. So here we're going to show the width and height. We've done that before. So we have 661 by 1000 almost, or 1024 width. All right. The first step is that we're going to want to perform cropping, which is simply we wanted to crop a section of the image. So here we are going to specify the top left coordinates of the desired cropped area. So if you guys recall in the previous lecture that we wanted to specify the width node and H node, which is specifying the top left corner of our window. So here I'm going to specify, okay, I need the width divided by 2 and height divided by 2. And that will be my width and height. The next step is that I wanted to specify the coordinates of the bottom right coordinates simply of the desired cropped area, which is W1 and H1. So I'm going to say, okay, I'm going to specify width and height, and that will be our H1 and weight 1 or width 1. Shift enter, looks good. Let's go ahead and actually crop the image. So I'm going to say, okay, go to my image and specify H node and H1, and then width node and width 1, and that will be my cropped area. And let's go ahead and actually see the cropped area. Shift enter, and here we go. So as you guys can see, we're able to crop pretty much half of the image, as you guys can see here, and that's how you simply perform cropping. It's really simple, very straightforward. You just specify the coordinates of the top left corner, which is half, pretty much half and half of the x and y, and here we specify the coordinates of the bottom right corner, which is simply the width and height, and that's why we're able to kind of get the quarter kind of the image, as you guys can see here. All right, looks great. Please go ahead and try to change, the width and height, and try kind of to play with it just to get an idea of how can we perform cropping. Again, it's really simple and very straightforward. Okay, shift enter, just to, if you wanted to actually visualize the image, so you guys can see here. Here we just plotted the cropped image, and we wanted to plot the original image. So if you guys recall, here obviously I'm using matplotlib just to visualize the values of the pixels here. So the original image was, again, as you mentioned, around, let's say 650 by almost 1024 pixels. And if we wanted to kind of crop this area, that's what we have done here. And we're able to crop almost maybe 50 by almost 500. As you guys can see here, we pretty much just got this area out of the image. Okay, all right, looks great. The last step that we wanted to perform in this section is how can we perform dilation and erosion operation. So first, we're going to load our image. So here we go, this is our image. The next step is that we're going to use OpenCV using the erode and dilate to simply kind of erode and dilate our image. Again, it's very straightforward, very simple. Here we're going to pass our image, pass our kernel. So here we specify the kernel of 3 by 3. And here we're going to specify the iterations, which is how many times you wanted to apply the effect to the image. So if we specify iterations equal 1, that means we just wanted to kind of perform it just one time, just once. Okay, simply apply the kernel to our image just once, and that's it. And if you increase the iterations, then you are going to increase the effect as we move forward. So if we press shift enter, here we're simply going to plot the image, the original image, the eroded image, and the dilated image as well. Enter, and here we go. So as you guys can see, this is our input image, this is our given image, this is our eroded image, this is the erosion, right? And this is our dilated image, this is after dilation. If you guys can see that simply the dilation and erosion kind of have been reversed. I've described that before in the actual lecture, but as I mentioned, that when we say dilation and erosion, we're not actually talking about the actual letters, right? We're talking about dilation and erosion, kind of the background. So when we say erosion of the in here, that means we are performing an actual, again, think of it as kind of we're reversing the operation in a way. When we talk about characters, this should be an erosion to our image, right? But however, here you guys can see that the actual letters become like thicker, right? And simply put, we took at the background, which is our the white pixels, as you guys can see here, we just eroded these pixels. So when we eroded these pixels, the actual letters become thicker, right? However, on the other side, when we perform dilation, again, here, this is the dilation. We perform dilation for the actual background. It's not the actual letters. So when we perform dilation, it's kind of, we increase kind of, the pixels in a way. And that's why the actual letters here becomes a little bit thinner. Because we dilated the white pixels in here, we move them forward into the actual letters, as you guys can see here. Okay? Again, please go ahead, review the lecture. But this is pretty much the overall idea. Think of it as erosion and dilation. They're going to be reversed for us if we have characters like this in the image. So the quick question, or the important question, is why do we want it to perform, let's say, erosion and dilation? So in self-driving cars, let's say if we wanted to, for example, classify this traffic sign, it would be really beneficial if this is our original image, to actually kind of, increase the kind of the thickness of the letters, right? Make them more clear, make the features more prominent. Why? Because when we take this image and we use it to actually train a classifier, or maybe train like a deep convolution neural networks, which is going to be discussed moving forward. If we perform, let's say, an erosion in this case, you guys can see that the actual letters becomes thicker, right? So it will be easier for the network to actually kind of perform the detection and perform the classification as well. So that's a better thing. So in general, we can take the image, perform an erosion and dilation before feeding all these images into our classifier. All right, looks good. So let's go ahead and maybe increase the number of iterations, make them, let's say, instead of 1, make them 3. So if we press Shift Enter, as you guys can see here, we improved kind of, or increased the effect. So here you guys can see the letters becomes way thicker if we have 3 iterations as compared to 1. And as you guys can see here, the actual letters becomes way thinner compared to this one as we increase the number of iterations. All right, and that's pretty much all what I have for this lecture. I hope you guys enjoyed it. Let's recap what we have done so far. In this lecture, we learned how can we perform image cropping. So simply, when we crop the image, we need to specify 2 coordinates: top left corner, W node and H node, and we need to specify the bottom right coordinates, which is H1 and W1. And we're going to pass along the cropped image, and we can easily just visualize the image, as you guys can see here. If we wanted to perform dilation and erosion, we just specify a kernel of 1s, and then we're going to specify the erode and dilate, pass along our image, pass along our kernel, and specify how many iterations you wanted to perform. And that will give us the image erosion and image dilation, as you guys see here. And please bear in mind that erosion and dilation are kind of, a little bit reversed when it comes to OpenCV, because OpenCV treats the background as the actual effect, or the actual kind of, like an object that we wanted to perform erosion and dilation, as compared to, let's say, characters in our case. And that's all what I have for this lecture. I hope you guys enjoyed it, and see you guys in future lectures.